right. So welcome back after lunch. Oh, wow. This is, I don't see you. I am serious. I don't see you. Just this row I see. So after lunch is 2 slots for public speaking is the worst. One before lunch, one after lunch. Both are terrible. So we need to make you entertain, not just give a talk, to make you awake for the next 30 minutes and hopefully the rest of the conference. And I think that's the reason they put me in this slot, because they think I'm funny. I'm not, of course. And also, we did something last 2 years. I've been here 2 years ago, same stage, and some of you probably have been here. And actually, we did something interesting, very ad hoc, very random. I think even organizer, including also myself, I'm not organizer, but I was surprised how well it worked. I brought 2 socks and I just gave it to one person from this row and one person from that row. And I asked during the talk, just pass these socks to your, like, wherever you see it, just pass it to the next person. And if we get to the last one, then again, do it the reverse, back to the first. Just do it like that until I say one word. You need to listen to me very carefully. When I say that word, then whoever gets the socks just needs to be standing as fast as possible and shout as loud as possible. Let's agree on which word you need to say. Let's say we need you can say Flutter connection very loud, like just scream. If you do that, you'll get the socks. Not only that, one of the socks has a very special thing in it. So hand it over to my personal assistant. If that person opens, please do not open and look at inside. Like, be very honest. Do not do that. And if that person opens the socks and find that surprise, we'll get my book for free as well. Take it away home. So I'll do it here so you get inspiration. It's 600 pages. It's supposed to stand. That's the reason I wrote 600. Okay. So now let's get started. I have actually a packed agenda already 5 minutes past. So that was not part of the talk. But I want to talk about memory leaks. And I will set some expectation, of course, for you, what you will get from this talk. And hopefully after this talk, I hope I will not see those kind of issues anymore in any Flutter code base. Please pay attention. These are simple stuff that you very simply overlooked, and then you get a problem at some point. You probably even have seen, maybe one of you have written this in even Reddit right now. Oh, my app is gradually consuming too much RAM. Oh, it crashed. How the hell is happening? Everything looks fine. What should I do? And you look at your code, you actually see everything is fine. You literally see everything is fine, right? But I'm going to pass this one because I was introduced anyway. And that's what we're going to talk about it today. Because we need to talk about Dart VM a bit and how garbage collection works. It's going to be too high level, but I will have multiple QR codes today. Please bring up your phone, scan them, and check them later. And that's important. Check them later. But scan them, keep the links, because there are multiple links that you can go deeper and understand even more. I'll go through the Dart VM for sure a bit, so we get the same understanding, and we understand why you get those consumption in the memory, even if you think everything is fine. I'm not on fire. And then let's have some samples and the most kind of issues that I have seen in the last 6-7 years of working with Flutter and in multiple different code bases. And I'll give you some also tools so you can hopefully utilize them to figure out. And obviously some best practices. This is expectation. Let's clarify one thing. So is when we're talking about Flutter memory, we're talking about both Dart layer in the architecture and the native layer. Obviously, we're not handling the native one for now. We're not even talking about it right now. So we're going to focus on the Dart and Dart garbage collection. So let's focus on that. But I want you to explore more on the native part, and you will find some links on it as well. Let's clarify one thing here. There are two different misunderstanding, let's say, about memories when I talk to different developers. So one is about memory bloating and another one is memory leak. In fact, when we're talking about memory leaks is a kind of problem that happens to the memory or in the heap, I say what it is, where gradually you're going to consume more and more because the garbage collection cannot free up the object that you created, right? And we will see how it happens in a minute. But then memory bloating is something that you deliberately do it. Maybe you're loading an image into the memory for caching purposes, for example, or you're loading your JSON into the memory or things like that, which suddenly you consume more memories, right? Both of them can degrade your performance or your application's performance. It's important that you clean up, at least for memory bloating, and also very important for memory leak. However, the memory leaks sometimes happens without you noticing because you think garbage collection is taking a good care of you, which it does, but there are some missing parts. Okay, I'll continue until we have the slides. But what happens is that the Dart actually comes with garbage collection. And what type of garbage collection it has, it's called it generational garbage collection. What the hell it means? For us, I simplified it for you. You're not supposed to just read everything here. You're supposed to listen to me and it will support my wording. You can take a look later. What happens is that when an object is created, so there are two type of kind of generation here. So one is the young, which takes care of the nursery. As soon as you create an object and there is no reference and no use, so the garbage collection will take care of that and will remove it from the memory and free up the memory. The second one, though, is for long-lived object. So the object that you create and it lives in the memory for long in time. And then it goes to the garbage collection. Garbage collection uses an algorithm called mark and sweep, which technically means, hey, I have an object, there's no reference, mark it for garbage collection, then go to sweep, remove it, and then free up my memory. Just simplified it here in this slide. You can take a look later. But essentially, I'll quickly explain it here. You create an object, it goes into the Dart heap or the heap. Heap is a host for your object, just in the memory, okay? So then you move on, you're gonna have a root object. Whatever object you create is gonna be the root. So everything then afterwards will get a reference to that. And what happens is that then your garbage collection take a look at these garbage collector, take a look at the references and say, okay, the root, the object that you created, will either have some kind of reference or it doesn't. If it has some kind of reference, then it will actually will be remained or retained, the correct word, in the memory. But if it doesn't, then it will go and be swept away, or the memory will be freed. So, okay. So why this is matter? Why does this matter? Because these are actually very nice when you create something that does not have reference. If you unintentionally create an object that keeps the reference in the memory, garbage collection cannot free up the memory for you because there is a reference, even though you don't need that object. Okay. To simplify the idea, here is just a diagram that shows you. Here's my the roots, and then I'll go through the references. The blue ones are the ones that are not connected to the root. Therefore, they're gonna be freed up. They're gonna be garbage collected. If you want to learn about the garbage collection or GC in Dart, strongly recommend you to watch Anna's talk in Flutter Vikings 2022. It's going way deep to the Dart VMs and show you how exactly this works. I just gave you 2 minutes overview, but it's way more than this. Now we must be happy. And this is AI generated. Disclaimer. Actually, this is fascinating. I have not touched the AI generated image at all. Those fonts, logo, everything is generated by the latest model of GPT, which is fascinating. But why this was important? Because there are objects that we call it disposable objects or memory risky objects. Remember these two words because we're going to talk about it a lot as of now. So the disposable and memory risk object are the ones that are a little bit tricky to clean up by the garbage collection. So the disposable objects are very familiar to you. The ones that you need to dispose in the widget lifecycle. Many of them you have seen, like controllers, streams, and so on. I want you to take a look at this code. Raise your hand and tell me if you are doing like this in your code. Don't worry, it's okay if you're doing. You're not on fire yet. Anyone noticing? Similar? If not this one, how about this one? Anyone using team.off context directly passing to a callback? You don't do that? Are you using team.off at all? Or is it very unfamiliar? What's wrong with this? Very simplified version of it is that like when you do this context, build context, passing to a callback directly within an object that's supposed to be long-lived, for example, team.off, and passing directly to the callback. So when the disposing happens in the life cycle of the widget, then the closure that is within that callback keeps a reference to that context. Why does this matter? Because your context actually holds some information about your widget tree, and then we know that in the rendering pipeline, it's not just a widget tree. We have then elements, we have then objects and render objects and so on, right? So it then makes slowly, gradually holding up to your memory without you noticing. That object is referenced, and if you're doing that in multiple pages, let's say, or multiple places, these are gonna stay, these widgets that's supposed to be cleaned up, they're not gonna be cleaned up. And the memory is not gonna be freed. So, well, then you go to your DevTools. By the way, if you don't use that, please do that. The memory part of the DevTools, it's so advanced. In the last few years, they spend a lot of time to making that good and really learn it. It's one of the tools I wanted to recommend. And you look at this and you see that, okay, my app is running. And then after a couple of minutes or just going back, and then you see your memory is going higher and higher, like without like doing much. What's going on? That's exactly the reason I mentioned. Because you passed the context, which is supposed to be a short-lived object, which is supposed to be garbage collected, but you passed it to a closure that gets a reference and will become a long-lived. then the garbage collection cannot clean that up. Therefore, to fix that, you just need to make it like this. Just an object that is higher than in the closure, so then garbage collector knows after passing that object, this is short-lived. I'm gonna clean it up for you. It's fine to use the theme of though, because that's supposed to be a long-lived object. You use theme everywhere in your application. Let's take a look at another example. You make this type of static kind of object. You do that, right? Don't lie to me, you do. I'm pretty sure. You probably forget, but you do. And that's one kind of problem here, because this is static static variables or method is gonna live in the memory. They're gonna go to the long-lived phase. So what happens is that, like, this is another example of just showing how generating a list can take a lot of space in your memory. Make sure you're cleaning up if you don't need that. What you can do for those type of caching, either it's intentional, then you must have some kind of cleanup method. In case it's not needed, remove the memory, remove the objects, make sure you're reducing less and less, or like creating some kind of limited size cache. This is just an example I did for this talk, but you can expand on it. Like, have some kind of caching mechanism that has a limited size. You make sure you don't go higher than that. Or another thing you can do, have you heard about weak reference before? Who has not heard about it? Just raise your hand. Fantastic. I love it. Now you learn something new. If not by now, at least now you learned. The weak reference is an object that is unblocking GC for garbage collect the object that you create, even though it's supposed to be like long live or whatever. So the garbage collector can quickly clean that up for you. Here's just an example. The weak reference comes with a target as you see as a getter, and it might be null. The problem with weak reference is that, so because it can be garbage collected anytime, then you always need to have a nullability check. This is super important. But at the same time, it actually helps you to make sure, okay, in this case, I'm pretty sure the garbage collector will handle this for me, even if I forget to clean up myself. Another example would be the weak, so now, oh, actually, this is an example I created for you. If you are doing some kind of caching, like you want to just load up your JSONs in some kind of caching mechanism, this is a type of example that I think you can use in your application. This is like for image, of course, but you can do for also other part, like JSON parsing or so on. Another one is going to be the weak map. This one probably you've heard, right? Have you heard about it? I love this. I love this conference. So the weak map, instead of the map itself, it helps you to, it unblocks the garbage collector to collect this object when is needed to be garbage collected, okay? So it's just, again, the problem with these type of weak objects are that they will be garbage collected at any time. You need to always check for nullability. And this one, finalizer. Who knows about finalizer? Just Salih, because? Yes, because he's crazy, he said. But finalizer, this is my favorite, but don't abuse it, please. These like weak objects and weak references are great for garbage collection, but also they have downsides. So you should really make sure you do what you do exactly what you want on that case, right? So, and the finalizer is actually giving you some kind of callback where every time is getting garbage collected, you can deliberately yourself clean up after yourself, like in a dispose. Like this is just a pseudocode right now, but let me just tell you exactly how it works. So generally, when you create a class or an object, When you register this callback in your callback, then at some point you have a finalizer somewhere sitting there for cleaning up. And whenever a garbage collector is going to take act and remove the unreachable and no reference, like let's say objects, then that callback will get called. This is between the time that is the garbage collection and the object is removed. So you're making sure you are cleaning up and making sure you're removing everything. So this is important. Why? Because imagine you have some kind of like, this is an FFI kind of example, and native memory leaks are quite tricky, in fact, to debug for us as Flutter developers, especially. So just to make sure you are freeing up the memory here in this case, I registered. Here is the registration. I attached my object right now to the finalizer that I said, hey, whenever you get garbage collected, call that callback and make sure you're freeing up the memory. That's just an example. Obviously, in this case, I have a dispose function myself. The dispose function will take care of that cleanup. But if you remove or if you forget to have the dispose function, then you are making sure that the finalizer, because you registered the cleanup, it will take care of that for you. That's just a safety. Because of that, you need to make sure in the dispose deliberately detach the finalizer so that you don't call the same thing twice. All right, so this is a kind of DB wrapper. This is very probably common scenario for you, right? You're opening up a DB and you make sure you want to clean up when the DB is closed or disposed. So a couple of other examples, probably very familiar to you, having a streams. Streams are the ones that you need to cancel them. Those are the type of objects that are not going to be garbage collected if you deliberately don't dispose them or cancel them. I'm not going to go through this because I know this is something that you're doing. Removing the listeners is quite a known practice. Another one is I wanted to recommend you to use things like cancelable operations. From async package, because this type of kind of object helps you to clean up at a certain time. So this is a good practice again for those disposable and tricky memory risky objects. So another thing I wanted to quickly mention, I have 5 minutes, I guess. Someone show me some. No, that I don't trust that because that was 25 minutes. Yeah. People asking about Word. Yeah, so making sure in the life cycle of the widget, I hope everyone knows in this room. Everyone knows? Yes. If in the life cycle, like initial state, dispose, and so on, making sure you're cleaning up, especially, I think dispose is the one that you're hearing a lot about. That's why I'm actually move on a bit faster. But what I wanted to show you is the did update widget. Anyone using this like in your application right now? Fantastic, like many of us, right? But we often forget to clean up from our previous listener, and we always come back and register a new one. So this type of cleanup is actually necessary to make sure you're sending a hint to the garbage collection that, oh, I'm done with this, right? So another example I wanted to tell you is about optimization. So how a simple approach or algorithm towards optimization can significantly reduce memory consumption. This is just an example, but obviously we can find many of them for Flutter and Dart. A concatenation of a string in Flutter or in Dart, actually. Very straightforward example, which we do all the time. Did you know that if you compare this, there are 4 ways of doing concatenation of a string in Dart. If you run the first one that I just showed you with plus, that's the worst one in terms of memory consumption. as well as the, of course, execution time. But then Dart has something called bytes builder, where if you use that instead, you can significantly optimize your code. That's generally important for janky kind of frames in Flutter as well. If you have somewhere in your application that you see some janks because of these type of concatenation, that's where you need to put some effort and optimize with better algorithm. Obviously, using const, I think everyone knows that, right? That's obvious. I'm not going to go through that. And also make sure you're always using some kind of lazy builders. So helping you to reduce the consumption. Imagine you have a long list of data in your screen. Why they need to be all upfront in the memory? They can always be built and disposed when they are needed. So this is the type of things you need to take into account. But last thing I want to mention is about tooling, how you can think about it. This is about very common practice in software engineering that the more you take this stuff to the left, which we call it shifting left, the easier and less expensive becomes, right? The more you have control in your development environment, the easier and somehow cheaper to do. So that's why having a static analysis, for example, is a good practice to do. You do have Flutter lints. Maybe you are using DCM, Dart Code Metrics, and so on. In fact, you can also right now use some tools such as Leak Tracker. I'll show you in this slide. There are a few packages from Flutter team and Dart team. Leak Tracker and Leak Tracker Flutter testing. This is what I really love. I know all of us write unit testing and widget tests, right? Fantastic. Everyone does. So then you can leverage the package to make sure during that calls of the testing, the memory is also be captured and make sure you are cleaning up in the development during testing. You can also use a leak tracker for that, obviously. I have two examples here. Like this is gonna be your leak tracker, just an example where you start and stop, and it gives you whatever notice that you need to know about the memory. And this is just an example about leak testing. Just as simple as that, when you use this package, you can actually incorporate it to your test and get some insight. So you will figure out during your development. This is an example of memory usage package. This is so experimental, by the way. Don't use it for production or just experiment for that. This one particularly. Okay, the video is not loading, but what I loved about this is that it loads your application and automatically snapshot when the memories are quite high. Unintentionally, probably you've done it. And then you can grab that JSON or that output, put it into DevTools and figure out where was that happening. No? Oh, someone said no. Here is an output. Then, for example, you can figure out here in this example, I exported. So I have this stack that I think in my returning path, this object needs to be garbage collected. Learn about DevTools for memory, please. And more importantly, I also do some part-time contribution to DCM. We recently announced a dashboard where I was surprised. I was working on a project myself, which I thought everything is fine. And then I ran that analysis, uploaded the data to our dashboard, and damn, I had 558 memory leak issues in my code. I was just like, wow. I thought everything is fine. I mean, it looks like that meme, you're sitting in the middle and the fire's around you, right? I was just like that. Everything is fine. So use the tool, please. I'm not saying this tool, but generally all the tools. Of course, this is the one that I recommend as well. But you can really be surprised how well a tool can prevent things that you cannot prevent, like always have it in mind. Like we talked about removing listeners. We talked about disposing methods or fields, objects. We talked about unused or unassigned streams, subscriptions, or even prefer bytes builder, these type of optimization. You can have these as an static analysis rule where it goes through your code base, your PRs, and always help you to catch as early as possible without you noticing, and also simplify development for your team. With that said, I have to promote my book, 70% discount. The code is gonna be Connect25, and here is the link. I give you 30 seconds right now for no. Obviously, no. No, sorry. And oh, with that said, thank you. What's the next one? There's supposed to be two. There was, yeah. Can you open your socks, both, and dig into it? See if you find anything. Maybe I should give it myself, right? I'm the author. You got the pin. Congratulations. Can you come up? No pressure. Finish it by tomorrow. Thank you very much for today. I hope you enjoyed the talk. You can find the slides. I actually had another slide to give you the slides link, but I will make sure that the organizers send you the link. You get all the slides. And with that said, if there's any question, if you have time, I can take it. If you don't, then I'm done. That's good. I'm always going over time. And that's it. It's not my laptop. Have a good day. Bye-bye. Thank you. Thank you.